Hi everyone, welcome to NEBS Design and Technology YouTube channel. In this video we'll be constructing the ellipse, just like in the other one where we constructed the ellipse using rectangle method. This video will be focusing on the construction of ellipse using the concentric circle method. Remember we said we have several methods that can be used in constructing the ellipse. We have the rectangle method like we had in the other video. We have the concentric circle method like we'll be carrying out now. And then we have the Trammell method. We have the focal point method. We'll be doing all those ones in subsequent videos that will be uploaded. So quick one, let's move on to the construction of ellipses in the concentric circle method. We'll be following the process in our e-notes and then we get to demonstrate it right on here for clarity's sake. Okay, let's consider to use the major axis to be 60 mm and then the minor axis of this particular ellipse we are constructing should be let's say 40 mm. So we have the major axis and the minor axis to be 60 mm and 40 mm respectively. Remember I said every ellipse has a minor axis and the major axis. So we need to consider that before we move into the construction of any ellipse at all. You'll be given the axis size dimension so that you'll be able to get to know what to do and the rest. So to construct using the concentric circle method, which is also the auxiliary method, we need to construct a concentric circle. Remember in our previous time we talked about concentric circle to be circles with different radius but same centers. They have same midpoints but different radius. So we have two circles in one sharing one center. So we get to make our axis, the dimension of our axis, the diameter of the circles. So we start with the minor axis which has 40 mm. It means that the diameter of the small circle, the inner circle, will be 40 mm, while that of the big circle or the larger circle will be 60 mm. So first we get to construct our coordinates for the circle. So construction of coordinates for the circle. So I get to make my virtual reference points where I will always place so this is my coordinates for the circle here. Now we consider the first one, the minor diameter, the minor axis to be a minor diameter, and they said the diameter is what, 40 mm. So our radius is going to be 20 mm. Our radius is going to be 20 mm. So we have this 20 mm. So joining the both of them together, the two radius side should give us 40 mm. So our major diameter has 60 mm. That's going to be 30 mm radius. 30 millimeter radius. So these forms are concentric circle. Concentric circle, circles with same centers but different radius, just like we have here. To construct our ellipse, we need to divide these circles into 12 equal parts. To divide our circle into 12 equal parts, you can just use the radial, your compass, or you can also make use of your set square. But for quick results, I'll make use of my compass, so I won't get too. So my compass placed on this end, I get to strike arcs using the radius of the circle. Now I'm dividing the bigger circle because it will also divide the small circle automatically, since they both share same centers. But remember, I'm using the radius of the big circle to do this. So after getting this axe, all you need to do is join it to the opposite, directly opposite point of intersect, like this. Like this, ensuring it passes through the center of the circles. And then the last one. Here. So we have divided the circle into 12 equal parts. So we have it as 12, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what we're going to do next is that we're going to draw vertical lines. Look at the step 3 of the method in your e-notes. So you should draw vertical lines from each point on the large circle to intersect the horizontal lines drawn from the corresponding point on the smaller circle. Now, we're going to draw vertical lines from each point of the larger circle. So this is the larger circle here, the outer one. So we're drawing a vertical line, and then on these corresponding points, we'll draw horizontal line. This is what it means. So I'll start from 1. I'm drawing a vertical line. So now my vertical line must be parallel to the y-axis of my circle. So I'm using the vertical line coming down. You can see that it is corresponding with, from point 1 and point 5, they both share the same vertical line. So point 2 and point 4 also share the same thing. And you may not need to draw them too long so that your lines won't intersect roughly. So I'm taking it 11 and 7 will also share the same vertical line, and then 10 and 8 will share the same, just like 2 and 4. Now, vertical lines from the larger circle and horizontal lines from the smaller circle. So your horizontal lines must also be parallel to the x-axis of your circle, of the circles. So ensure you're doing them rightly so that you have the best results. So I'm starting from 4 here. You can see that when you draw your horizontal line, it should intersect with the previously drawn vertical line. So 4 and 8 are having the same thing. Point 7 and 5 here. You can see that. So I'm going up to point 2 and 10, drawing the horizontal lines to intersect with my with my vertical lines that was drawn earlier. Then point 1 and 11 also. So with this we have established points of intersections, and these are these points here. So we can now easily trace our ellipse from this point. So I'm just going to dot them out for you to see. So there's another intersection here, another intersection here, another intersection here, another intersection here, another intersection here. Here is another one, and that's it. So we are meant to trace our ellipse through this point of intersect. Now you can use your French curve, like I said, you can use your plan, and you can use your freehand, provided you are good at what you're doing. So I'm just going to have it this way. Ensure your curve is matured enough and neat. So there, that is it. I will have to trace it out. So this is the expected ellipse. So you can see that it is not it is forming tangents with, on the major axis. The major axis is forming tangents with the large circle, and the minor axis is forming tangents with the smaller circle. So this is what is required of you to construct for the concentric circle method, or the auxiliary circle method. Thank you.